Last night I was going to print off another copy of a schematic, and instead I printed an image of the board layout, and this came out better than, well, I didn't even expect this, but I'll take a moment to explain something. One of the things about a board like this one is very dense. Things are very close together, and in laying out the board, the silk screen, which has the parts list and everything on it, for instance here Q27, I couldn't put Q27 label inside here because of the pads. Put it on the edge here. What happens is when you go to the when you generate the Gerbers and you go to the manufacturer to get the board fabricated, any print that overlaps a pad, let me find one that's pretty significant. Here's one. This capacitor here, the letter C for C60 overlays the pad. Well, there's a solder mask here, and since solder is going to be used to, you know, insert the component and you solder it in, this will not be printed. So when you're looking at the board, you can't see this, and this is going to be helpful in constructing. So this is going to be included in a manual that I'm writing for this project for the few of you that are going to do it. All right, I've gone and taken the board and I've installed this part of the transmitter, which consists of an amplifier, RF amplifier. I've replaced these two IF transformers with two inductors, two variable caps, and two fixed caps. Then there's these coupling caps. One thing that's new here is there's not a transformer here, so I put a resistor in here to the collector of Q18. I put a 1K in there, and this is just swagging it, just guessing at it, and I'll have to optimize that. Then we go through here the RF amp, and then coupling to the final stage. So everything's finished in the transmitter except the power transistors. Okay, this is a receiver. So I got the board here, and this is what it looks like, and this is the section that I've wired. Now there are two fixed caps here that are in parallel with these two inductors to make the bandpass. Now these two Murata trimmer caps here are 180, so they more than cover the value I need for the 7 megahertz bandpass. And what I'm going to do is set these two for maximum transfer out. And these are friction fits, so I'll pull them out, measure them, then I'll determine the values for the two fixed cap, and then use something like 10 picofarad or 30 picofarad in here for the fine tuning. So as you see, I've got everything but the RIT, which I'm going to do last, and the power amplifier. There's a bandpass here. I didn't put the two trimmers in there because I didn't find them until recently. And then I've got to do the low pass filter, and we're done. So let's check this out. We need my speaker. We need a power supply. You know, handy dandy. I've got to check, see if this thing's charged. I've been using it for what, weeks now, but this doesn't draw too much. Good news, receiver still seems to be working. So let's see if we've done anything here. Here's my high dollar straight key, so hook it up to ground, and then we'll key the pad and see if we hear a tone and if the tone's any louder. I hear a tone. I don't remember if it's louder. Maybe it is. Hopefully you can hear that in the video. what I need to do is, and I'll have to find my general coverage receiver and see if I can find it. There's a couple of experiments I can do now. Let's see what happens if we hook an antenna up here. Now, this bandpass filter, without it installed, I can still connect an antenna, and I should be able to hear, noise. Uh-oh. I'm sending the receiver into oscillation. Now, I've used 2N4401s on this project. I'm going to come back with a second build to use 3904s, and I'm going to use J310s for the JFETs, and that'll be my final build, hopefully. I'm getting transistors for a little over a penny a piece, so the most expensive parts in this transceiver are toroids. You can get those for, what, $1 a piece. The crystals you can find on eBay and maybe AliExpress for 10 cents a piece or whatever. I'll come back with a manual, and in the manual I'll show you where I got the cheap parts. Okay, now let's see okay, now let's do a simple test here, see if I can find out where the oscillation's coming from. Okay, we know that this is let's see here. Oh, well, that's not what I want to do. I want to key the key. Oh, yes, it was. Sorry, forgot what I was doing. Antenna. Let's feed it through the IF. Now, one of the things I don't have, but I'll put on here a grounding pad for the crystal case. K8IQY, Jim Kirchie at K8IQY.com has an article on measuring crystal parameters and everything, and he did a test of what grounding the case does for your bandpass and everything. Now, I'm typically do not ground crystal cases because I'm never going to get a signal strong enough that I worry about what is called blow through or whatever, overloading this thing. But anyway, here we go. Now what that is noise at 4 megahertz, because that's the bandpass to the crystal. I'm feeding a signal from my, quote, antenna, greatly reduced because it's a capacitive coupling to the circuit, and the circuit's not overloaded. Now let me get my receiver here, and let me feed a signal let me feed it into Q5. So this will be part of the IF amplifier, and then the mute in the audio. What do I need? I need a Q5 or Q4 for the IF amplifier. Q4, that's there. Now remember, the signal's coming through the chain in this direction to the audio, so this is past the IF. Let's see, Q4, Q5. Okay, that's very loud. So what this tells me is that the audio oscillation is being generated here. Let's go to the input of the audio. Let's see here. What do I need? This is C7. Do you know where C7 is? Speeding along here. Whoops. C7. C7. Give me a hint. There's C9. Where's C9? C7. Sorry. Should look at the layout. There's C1. Whoops. C7. Let me stop here and find this. I'll be right back. All right, that's why you need this. Here's C7. It's just before the volume control. Well, I can feed this. Okay. So here's C7. Okay, so that doesn't affect that. So my oscillation is caused somewhere in overloading. I thought maybe it would overload. It was overloading the audio thing here, but it still may be. What I've got to do is I've got to take out. Where is it? I've got, oh, here. I've got to take out my little 50K here and put in a volume control and see if adjusting the volume control, it could be that I'm getting so strong a signal through the receiver that when it gets to this point, it's generating too much and sends things into oscillation. The old joke is, if you want to build an oscillator, build an amplifier. If you want an amplifier, build an oscillator. And the thing is that I may have, because I used high gain transistors in here, I may have too much gain in the audio. But I've got a very sensitive receiver. I just got to tone it down, and I'll be back. Thank you for your patience, your time, and the likes. And we're almost done.